Hello class, today we're going to go ahead and go over 2.5 notes in Algebra 2. These discuss direct variation. So let's go ahead and go over some vocabulary first. Direct variation is a linear equation in the form y equals ax, where a is the same as m, it's the slope, and your y-intercept is always 0. The constant of variation is a, which is, again, the slope. So really, this is just the linear equation y equals mx plus b, but the b is 0. Let's go ahead and look at some examples. In example 1, it says, write and graph a direct variation equation that has -3, -9 as a solution. So let's go ahead and look at that point first. -3, -9. So we know that that point is on our line. We also know it's a direct variation equation, which means the point 0, 0 must be on the line. So we're going to use the points 0, 0, and -3, -9 to write our equation of the line. We'll start by finding slope. Write my slope formula down here and substitute. -9 minus 0 over -3 minus 0. So I get -9 over -3, which means my slope is 3. So y equals ax, and remember a is the same as m, so I'm going to replace the a with 3 to get y equals 3x. That is our equation. Now let's use this equation, graph it, and see if we go through those points. So first of all, for y equals 3x, our y-intercept is 0, 0. So we're good there. Then our slope is 3, which means you can either go up 3, right 1 to graph it, or going back to the y-intercept, you can go down 3 and back 1. If you go down 3 and back 1, notice we do in fact hit that point -3, -9. So I'll go ahead and draw my line with arrows on both ends, and we're done. In example 2, it says Hooke's law states that the distance d a spring stretches varies directly with the force F that is applied to it. Suppose a string stretches 15 inches when a force of 9 pounds is applied. Write an equation that relates d to F. Okay, so notice varies directly. Direct variation, that's what we're doing right now, right? And our direct variation equation is normally y equals ax. So, in this case, the distance varies depending upon the force, okay? So our distance depends on the force, which means the distance is our y, so I'm going to replace y with d, equals a times f. So d equals a times f is our equation. Suppose a spring stretches 15 inches with a force of 9 pounds. So they gave us that a d, distance, is 15, and f, force, is 9. We're going to plug these in to find our constant of variation. So for d equals af, I'll have 15 equals a times 9. To find a, I divide both sides by 9. This gives me a equals 15 over 9, but I need to simplify that by dividing top and bottom by 3. So my a is 5/3. I found my constant of variation. However, we are not done because it says to write an equation. So that equation is the d equals af, except for a, we're going to write 5/3. So d equals 5/3 f is our equation. It's really important that you remember to write that equation after you find a. Now, part B says predict the distance that the spring will stretch when a force of 6 pounds is applied. So we're using that formula from part A, d equals 5/3 f. They told us that the force is 6 pounds. So I'm going to replace f with 6 and solve. d equals 5/3 times 6. To multiply a whole number by a fraction, you can put the whole number over 1, and you can multiply straight across if you want. If I do that, I get d equals 30 over 3, which means the distance is 10 inches. And that's it for that problem. In example 3, it says the dimensions of 5 rectangles, each with an area of 24 square feet, are given in the chart. Tell whether the length and width show direct variation. If so, write an equation that relates the quantities. So let's look at the differences in x and y. So in x, we're going up by 1 each time. In y, let's see, there's a difference of 12 here, a distance of 4 here, a distance of 2 here, and a difference of 1.2 here. These do not have a constant change. Since their change is not constant, that means this is not direct variation. So we are not going to write an equation. Okay. In example 4, it says graph the equation 3x plus 5y equals 20. So this you also saw standard form in the previous section when we were graphing in 2.4. Remember, there's 2 ways you can figure it out. I'm going to go ahead and find the x and y intercepts to do it. So for the x-intercept, I'm going to make y 0. 3 times x plus 5 times 0 equals 20. I'm going to solve for x. So 5 times 0 is 0, so I get 3x equals 20. Divide by 3. X equals, let's see, 3 goes into 20 6 times, and you have 2 left over. So it's about 6 2/3. For the y-intercept, I have 3 times 0, so I make x 0 to find the y-intercept, plus 5y equals 20. 3 times 0 is 0, so I get 5y equals 20. Divide by 5, and I get my y-intercept is 4. So I'm going to be plotting the points 6 2/3, comma 0, and 0, 4. So 6 2/3 will be between 6 and 7. And 0, 4 is up on the y-axis. Once I have those 2 points, I can connect them with a line and arrows. You could have also rearranged the equation into slope-intercept form and then graphed it as well. That would have also worked. And that's it for the notes today. If you have any questions, be sure to contact your teacher.